Hello, everybody. So this is the video dealing with section 6, solving systems of equations graphically. And I should say solving systems of linear equations graphically. This topic is not very important because we have two other techniques, which is solving system of equations using substitution method and the addition method. So those are way more important techniques, and we'll focus on those. But since this is part of the course, I'll go over one example with everybody here. Now, when we solve these systems graphically, we'll have two equations, such as these ones that you see here in problem 6.1. And for both of these equations, we are going to have to rewrite the equation into y equals mx plus b format, and then we'll graph both of them on the same axis, on the same graphing paper. When we do, we will be able to get three possible solutions depending on what equations we have. This is the most common one, that when we graph both of the equations and trace a line through the points, we will have either one unique solution, 1 point, which is this case right here, you see 1 point. Sometimes we may have a situation that the lines will be parallel, they never intersect. This will be this case over here. And in this case, we say that there's no solution, okay? And on the exam, we would have to write no solution. And the third case is possible that when we graph the two equations, as you can see in this example, that the equations are exactly the same. So one line is on top of the other, okay? And that means that we have infinitely many solutions. So you would have to write this on the exam. So these two cases are not as important as the first one. So I'm going to go over an example dealing with a unique solution for you to see how this is done. So let's take a look here on this problem. So remember, I am given these two equations. I have to rewrite both in the format y equals mx plus b. Now, m, you remember, is the slope. And the value b right here, plus or minus, is what we call the y-intercept. Okay, so let's do that before we begin, because we need to do that. So 4x plus 2y equals 14. So I'm going to subtract 4x on both sides. I cancel here. I get 2y equals minus 4x plus 14. And then I'm going to divide everything by 2 because I want the answer in terms of y. So I get these two cancel. I have minus 2x plus 7. So in this case, I am going to always rewrite, if there's no fraction on the m, I'm going to put it over 1, and you see why. So this is the slope, minus 2 over 1, and this is the y-intercept. Now, so look what we do once we are at this point. So let me make this a little bit bigger for you to see. So this is step 1, right? And maybe I am going to do also the same thing. Let me just write it over here. Minus 3x plus y equals negative 3. So this is probably faster. I just add 3x on both sides. I get y equals 3x minus 3. And again, because there's no fraction, I'm going to put it over 1. If there was a fraction, you just leave it that way. So this is the slope, and this is the y-intercept. So I have my two equations in the proper format. This is what we do now. We are always going to begin by plotting the y-intercept first. Okay, so in this case, it's 7. So let's see, 1, 2, 3, 4, 5, 6, 7 is right here. And then we're going to look at the slope for the first equation, which is 2 over 1. This is the slope, which is, if you remember, rise over run. So this is how we proceed with the graphing. You're going to take a look at the rise. In this case, it's negative. If it was positive, you would go up from the y-intercept. Because it's negative, you're going to go down 2 units on the y-intercept. So I'm going to go to here. And then I am going to do the run, which is always to the right. And in this case, I'm going to go 1 unit to the right. Okay. So again, you will plot the y-intercept, 7. You will then take a look at the slope, which is in this case -2/1. So rise -2, you go down. If it was positive, you would go up from the y-intercept. So 2 units down, run always positive to the right. And I have these 2 points. Once you have 2 points, all you do is trace a line through them. And now keep in mind, my line is not going to be very good because I'm doing this on the computer. But you'll have graphing paper and you probably have a ruler. It will be easier. So this is the first equation. We'll do the exact same thing on the second one. So begin with the y-intercept, which is -3. So here is -3. And on the slope, you do rise 3 units up from the y-intercept. So 1, 2, 3, and 1 unit to the right. So here are my 2 points. Once I have it, I am going to trace a line through them. Let's see if I can do a good job here. And yes, it's very hard to do a good job on this thing. So it looks like it intersected right here, given the little discrepancies because of my imperfections. So then this graph intersects in one location and the coordinates are 2 and 3. So this is a unique solution and you would write on the exam solution 2, 3. Okay, so this is how you graph, find the solution using the graphing method. First, you rewrite both equations into y equals mx plus b. You then plot the y-intercept for each one, and then you do rise over run on the slope from the y-intercept. In this case, there was a single solution, but there could be, lines could be parallel, no solution, or they could be on top of each other, which is infinitely many solutions. So this is the technique of solving equations graphically.